Thanks for having me. I'm Błażej. I came to you today from Kraków to present this talk. It's going to be about managing objects inside your application, managing dependencies between them, and a lifetime of those objects. So this is very generic topic, totally cross-platform. So I think it should be interesting for both iOS and Android developers. Just a disclaimer, this is a talk based on my experience with some recent projects. Hopefully you will find this experience useful for your own work. And I also will be glad to hear your feedback and your opinions, how you handle this in your applications, in your projects. Perhaps there's even better way to handle this. Okay, yeah, this works. The agenda is that we are going to talk about what is the issue that we are trying to solve, and I will briefly go through commonly seen solutions that I've encountered working with either something that I came with at some point of my career, or something I would see in projects that I would have to work with legacy code that I've seen. And finally, the ultimate solution with a blink of an eye. I really like it. I think it's good, but I'm aware there are different ones, so you might like it or not. Hopefully you will. And yeah, so the problem statement. The thing is that application software is built with many objects. And all those objects, they need to talk to each other, which means that they depend on each other, those objects. You cannot have one without the other. And this ultimately is a major challenge, because you need to control those dependencies of those objects and lifetimes. If an object depends on another one, then the lifetime of those objects also is connected. So it is something that can be a bit challenging. Before we continue, just a short question, because now that I think about it, the way I encountered this problem is that some time ago, pretty late, it's a bit, I'm a bit ashamed to say that, but I started unit testing my code like 3 years ago, maybe, really doing it, testing everything. And this is when I noticed the need to actually be able to control those dependencies and lifetimes of the objects. So a quick question to you guys: how many of you unit test your code or test? Okay, that's good, because probably the problem that I'm trying to describe is something that you've also encountered, and perhaps you already solved it, or maybe you are struggling. So in that case, help is on the way. So the problem is that no, this is not the problem. This is ideal solution. You have a class and there's no dependencies. Wow, it's pretty easy to test it. You can just call functions, look at the output, and voila. However, if you have a class which inside has some dependencies, then it's not that easy to test this class, because, well, if there's a lot of those dependencies, then during the unit tests you will have to create all those objects, which might be expensive, because, for example, B or C could be like a network, networking kind of an object, or could be a database. This is definitely not something you'd like to instantiate in your unit tests. So, and this is just the beginning. You can have even something more complex, where it goes one level deeper, where you have object A, which is dependent on the B, A, and C. And then you have object D, which also is dependent on C. And here, the issue is that you might need to have the same instance of C inside of A and D. And how do you do that? How do you like inject the same instance of C into A and D? And also another question: how many of you are familiar with the term dependency injection? Okay, cool. I see that's like the majority of people. So that should be easier for you to understand what I'm trying to propose here. But before I propose what I recently started doing in my projects, I wanted to go through something through common solution that I've seen. So obviously, singletons. I'm pretty sure like everyone seen those. This is one way to solve the issue of managing dependencies between objects. You just create a static method through which you can access a shared instance of a class. So that will work, but obviously it has its shortcomings. There's been like plenty of presentations and talks on singletons, why they are bad. They have their place in software development, granted. However, most of the time, probably these are things to be avoided, so I'm not going to go any deeper in singletons, why not to use them. However, there is another approach, which I would call top to bottom. Maybe there is like a proper way. To be honest, I've never studied like a proper computer science, so if you guys have like a better name on this, just feel free to interrupt me. But I called it like top to bottom. And what it is, basically in a graph object like this, where object D depends only on B, but on the other hand, at some point, this object D wants to create E, and E depends on A, then the object D would hold, like from the beginning of its lifetime, it would hold A as a dependency because A is needed for E. D, actually, is there? Oh, awesome. So D doesn't really need A, but it's going to hold A all the time just to be able to create E and inject it there. So this will work, but it does have some problems. Like, maybe how many of you have seen this, or maybe have you seen something like this in code that you work with? Like, okay, yeah, it has some nice good sides about it. It eliminates singletons, an approach like this. And it's pretty easy to understand. Hopefully, I was able to kind of explain it well. But that's it. On the flip side, it makes testing pretty difficult because if you would like to test that root object, then you would have to mock all the other all these dependencies, which are actually like all the dependencies you would have in your application. And then it introduces tight coupling at the top level. I call it tight coupling with quotes because really that root object doesn't depend on those other objects. It just passes them down the hierarchy of the objects. But kind of indirectly, it has access to those objects, so it is kind of like tightly coupled with them. And well, yeah, finally, all objects in your application have to exist in your application lifetime in order to be able to pull this off. So this is also not ideal. And so that's one way to handle this. Another one that I've seen, which is I would say slightly better, but still not ideal. It's something I call like naive dependency container. And this basically is like a class struct which holds all the dependencies that you are using in your application. So the way it works is that all the objects in your application have access to this container, either like statically through a method, or maybe it's just injected like from one object to another, just forwarded down the hierarchy of the objects. And I would say it's slightly better, but still not ideal. Have you guys maybe seen this? How many of you have seen something like this? Right? Yeah. So it's even more popular. Yeah. So, but it also has it has some pros. It's still, I would say, easy to understand, and here it's also easy to control lifetime of the objects, because inside those containers, you might hide the dependencies, the objects, behind some APIs. So you may always create like a new instance of a particular class when it's accessed through this container, or maybe you will always vend the same instance. You may have inside strong or weak dependencies. So controlling lifetime of objects inside that container is pretty easy. So that's a really big pro of this solution. However, it still introduces tight coupling everywhere, kind of, because every object has access to like everything that is inside the container. So only by convention, objects are not using that other dependencies that they shouldn't be using, if that makes sense. I hope. Yeah. So yeah, that's another solution. And finally, one that I really like and I've been using for a while is default arguments. And here, the solution to dependency injection is that we are using Swift default arguments in an initializer. So, and interestingly enough, the B dependency is created like as a new instance for this class, but C is is taken from a shared instance. This is very useful because you can actually still be able to unit test this and inject other mocked, for example, instances. But if you are not testing it, you don't mock, and then you are using the default arguments. So very convenient. I would say it's still easy to understand because when you're looking at a class, you see everything in one place where the dependencies come from. So that's nice. And it promotes loose coupling, so that's also good. It's like the it's a bit different than the like two previous solutions, which were rather tight coupling kind of solutions. However, still sharing objects here is done with singletons, which is not great, and controlling lifetime of objects is rather limited. Like without some complex, maybe not complex, but some hacky ways, you are either injecting new instances of objects inside in that init default arguments, or you are using static, so shared global instances. So you have like only two ways of controlling lifetime of objects. And then, so this is like the last solution that I wanted to kind of present you as a commonly seen one. And I would say that the last two solutions are something that I would say is like not bad. However, you can do better. And here's the ultimate one. And to be honest, I'm pretty sure like this is not like super special. It's been in software development before. It's not like I invented this. It's just that I'm not sure how it's called. I've looked on Google. I tried to find an answer, and possibly inversion of control container is like a proper name for this. But don't be scared by this name. It's rather easy It's a pretty easy idea once you understand it. An easy concept, yeah, I was going for that word. Yeah, so let's try to understand what it is. So it's kind of similar to that naive dependency container in a way that there is like a single object inside your application which holds other objects. However, it doesn't like create all those objects at the lunchtime, and instead it just provides an entry point for your application. Could be like one, could be more than one. Usually it's related to something like a root view controller, which is like a first view in your application, or maybe it's related to some services that your application needs to create in a response to push notifications. So there isn't like many of those entry points. And those are like those are either objects that are created at the beginning of your application lifetime, or like factory methods that you would like provide to like app delegate or something like that. Yeah, let's look how it would be used in the similar DEF objects diagram. So let's say that you have object D which depends on B, and that dependency container will give you a method to create object D, and you really don't care where B comes from. And I will later explain why you wouldn't care about that. And object D also wants at some point to create objects E and F. They are dimmed here with like a dimmed color because depending on like the interactions with user, for example, your application might be creating E or F, or maybe it's not going to create any of them. So you don't really need instances of E and F. What you need are factory methods to be able to create E and F objects on demand. So, and yeah, E and F possibly will be created, and they will have some dependencies. However, those dependencies, C and A, are not something that object D needs to care about. It shouldn't. It shouldn't depend on them. You shouldn't care about that. So that's like an ideal situation to which we want. And it's possible to get to this point with the IOC containers. And yeah, let's look at the code. So this is the final slide, I think. So I will try to explain the code, and feel free to ask questions, because I'm not sure if I'm presenting it in a way that is understandable. So let's walk through this class, and then feel free to ask questions. So a simple dependency container following the principles that I described would look like this. It would be like one class. You could probably create this class in app delegate and then use it. The only public method it has, which is make root view controller. So from the outside world, this class vents only this method and returns object D. And inside this class, all those private methods are kind of like a configuration of dependencies within your application. You can see that when we are creating object D, we are using some static, sorry, not static, but constant instance of B, which is kind of like singleton, but not really a proper singleton. And it would be in future, if we ever decide that it shouldn't be like this, it's pretty easy to change it inside the dependency container. And also, we are providing factories. This is where it gets interesting. So we are actually providing factories, just blocks, which are able to create objects E and F. But here, even inside this make root view controller method, we really don't care how object E should be created. Really, what we care about is just a function that we are able to call and get object E. And under the hood, that function is able to create instances of object A by injecting some other dependencies taken from this container. So, and actually, the interesting thing is that once we create this first instance of object D, then we actually don't even have to hold a dependency to the dependency container. And that's because this is a bit mind-boggling if you haven't used those dependency containers before, but it's a cool feature of them. You really don't need to hold a dependency a reference to a dependency container, because if you hold a reference to object D, then object D holds the references to function E and function F. And I'm saying function, but these are actually methods of the dependency container. So you could imagine that, maybe I should have done that. It's actually self.makeE and self.makeF, which means that object D is actually holding a reference to the dependency container. So interestingly enough, the lifetime of the dependency container itself will be like only as long as it needs to be in order to kind of fulfill all its duties. So at some point, if there won't be like any, in object hierarchies, if there won't be like any objects which have access to factories from the dependency container, then the dependency container itself will be deallocated. But it's kind of like, well, I'm telling you that, but it's probably not something you need to understand to use those dependency containers. I guess that's it. So you guys tell me, is this something understandable? Do you have any questions? Maybe let's start like this. How many of you like, to how many of you it was like understandable? Did you get it, how it works? Okay, awesome. So I was so afraid that it would be like difficult to explain. Cool. So in that case, for those of you who still don't get it, do you guys have questions? Can I help to maybe explain it? Because that's my goal, to kind of sell you the idea and either like get your feedback and maybe make you to use it. Or like what's the mind-boggling part? Yeah?
I have a question. Who instantiates the container? Who owns the container?
So this will, I will give you an answer valid for iOS applications. Hopefully, Android developers will be able to kind of still understand it. In an iOS app, I would create an instance of the dependency container inside app delegate, and only there. Like, this container shouldn't be accessible anywhere else. It's you need only one place to create it, and then you will use only one entry method because it's like the only public method. Make root view controller, and actually, once you do that, you don't even need to hold the reference to the container inside app delegate. But that kind of depends. If you have other entry points to your application other than launch, maybe you have launch with notifications, then you probably would want to keep it around. But yeah, the simple case is you can keep it always around. Yeah. it's not like, so as I said, it's not something I invented. There are frameworks which kind of work in a similar way. There's something called SWI injection. Have you guys maybe heard about SWI injection, dependency injection framework? Anyone heard about it? I see some people did. So SWI injection works kind of like that. However, SWI injection has DSL, like domain-specific language, special syntax for defining those dependencies between objects and for controlling lifetime of the objects. And for some people, SWI injection could be like something simpler to comprehend and use. I kind of prefer using it, like not using SWI injection, because like it's easier for me to kind of like debug it if something goes wrong and understand everything. However, it's if you are using SWI injection, it's a very similar concept. Yeah. So, any other questions from like those of you who also like do understand the concept? Oh, sorry. Yeah. Yeah.
Yeah. I mean, I've seen a code base where it was in Java where almost everything was juice. We were using juice, and it was completely dependency injected.
It was calling what?
It was all dependency injection.
Yes.
It was great for testing and all that, but the greatest problem was when new engineers came, they couldn't understand it. So that's the downside of it.
Yes, there is a learning curve to that. And about all code base being done with this, I think if you really want to get all the benefits, you either create all your application with this concept of dependency injection and dependency containers, or nothing, because like only doing a part of your application like this could be a pain in the ass, really. But yeah, the other part of your comment that it could be like, difficult for newcomers, that is true. Although people that I'm working with, like all of them have been like convinced to use it, and they really like it. They are using it in other projects. So I think once you understand it, it's a useful tool, and people actually like it. Yeah. And to like further advocate this, I would say that this is highly testable, because your objects only have are like accepting in initializer those dependencies that they really need. So you can easily mock them and mock only those that are needed, and promotes loose couplings, because like really your objects don't need to know about like anything that's like in your application. They only need to care about themselves and the like dependencies which are hidden behind protocols. And finally, it's easy to control lifetime of the objects, because inside that dependency container you can have, for example, lazy initializers with weak references, which would work in a way that when anyone inside your application needs some object XYZ, then it's created and injected to that dependency that needs it. But the dependency container would only hold a weak reference to that XYZ object. Therefore, once it's no longer needed, it will disappear, so it won't like take memory in your application. It could be useful if you are like really memory constrained, for example, or for whatever reason you want that object to become. And it's easy to understand, really. Once you start using that, and then it's trivial. Like when I'm looking at some other dependency injection tools like assembly, I've been using that and still don't understand it. But with this, I think it's like pretty easy once you start doing that. Yeah. Any other questions?
Do you split this into separate classes, or you have one very big one for every field?
Good question. That's something that at some point everyone will encounter. So different approaches here. In my opinion, the most natural approach would be to have one container per one module / target in your application. That said, it kind of assumes that you have more than one module or target in your app, which is, by the way, a pretty good idea, especially for a good, bigger apps, to kind of split them either horizontally or vertically or both, because that way, like the modularization in your code base is high, and that's generally good. And then it comes very natural that you have one container for each target. You could, however, have several containers in one target. I haven't tried that, but I have friends which are using Swinjection, and once again, it's like a very similar concept. And they would use a separate Swinjection container for each screen / view controller, each screen of the app, although that could be like more than one view controller for each feature of the app, let's say, kind of like that. They would use a different dependency container. However, it has some, it's not that trivial, because you might, at some point, you might be in a situation where you have two dependency containers and they have objects of some particular class, and then you would actually want the same instance of that class to be in both containers. And then you would have to either like inject that at the beginning or do it in some other way. So having several dependency containers in the same target probably needs some more, consideration, I would say. Yeah.
How you pass the data between different controllers within the same container? So from one controller to another.
Like a view controller?
One object to another. That both are in the same container.
Okay. So I think I understand the question. So let's say we have, but nevertheless, I will kind of give an example, okay? Just to confirm that. So let's say that we have like a list controller and then a details view controller. And the question is, how would I pass, for example, a selected object from a list controller to the details controller, right? Okay. It's really no different from what you would do without dependency container. Like, I would even say it's like not directly related to the concept. It's basically the delegate would be the details view would be okay. No, so it is related. Yeah. Now that I think about it, it is related. It is so. Let me go back.
Do you have to go back to container with the data you want to pass, and then it goes on the other side?
Yes, but you don't need to know about that you are going back to container. Okay. So the way you do this is, let's say that this is some method that is going to create this details view controller, right? It's not taking any arguments, but it could be taking arguments, right? So it could be taking some item, some struct for like anything, right? And then you would be injecting not a method with a signature void returning D. You would be injecting a method with a signature something that takes like some input data and returns returns E. So, and that's it. Then your root view controller would be holding that factory method which takes an argument. And at some point of its lifetime, that root view controller would just call that method and provide that selected item to the factory and get the object. Yeah. And this is where I think this concept is better than Swinjection, because in Swinjection, I think it's not that clear what's going on. And here, under the hood, once you really this view control, this container, these are just plain Swift methods and variables and constants. So it's easy to debug, to follow the data, what's going where. Yeah. But yeah, I thought it's like trivial question, but it was like really good one. Thanks. Anything else, guys? Then thank you.